In this module, you're going to learn about methods. So what is a method? Well, it turns out that it's just a series of statements that's put into a block. A block is a series of statements in between curly braces. So a program that wants to use a method calls the method. You can also call it invoking the method. And when it calls the method, it supplies the method with information it needs to be able to do its job. So think about WriteLine. WriteLine is a method. It's a system-supplied method. You provide it the string and whatever formatting characteristics you want to apply to the string, and it goes off and prints whatever you've sent it to the console. So you call the method or invoke WriteLine, and you give it the argument, which is the string. In C#, every executed instruction is performed in the context of a method. So I'll show you what that means, but as I mentioned with WriteLine, ReadLine as well, and there are several others, you've been using methods since the very beginning of this course. So let's take a look. So here's a very simple C# program. It's the iconic Hello World example. And the first thing you might notice is that there is a line here where you describe main. The main part of your program goes here, but the important thing to note is that main is a method name. This line defines a method. Now, it's not a method that another program is going to call or that is called from within your program. It's a method that's called by the operating system in order to get your program to start. So it's a special method, but it's a method nonetheless. So you've been defining methods since your very first program. A method has a header, and then it's got a body. And then if you take a look here, this is a method invocation. So WriteLine is a method. Hello World is the argument it takes. And when you run this, WriteLine figures out how to take this string and publish it to the console. So why are methods important? Well, you can create your own. So what I showed you in Hello World was that you've defined main as a method, and you've used built-in system methods, but you can also create your own. Why would you want to do that? Well, they can be used to simplify your code. So if you think about programming assignment 3, one of the characteristics of that program is that it had a very long main method. If you think about how you might break that up into bite-sized chunks, you can imagine having a program that's a little bit easier to think about. Then also, methods enable you to reuse code. So if you find yourself writing pieces of code in your program that seem very similar to one another, sometimes you can extract them, generalize them, and use a method to satisfy the need of that bit of logic instead of having to write the same code again and again. I'll show you an example of that in a little while. There is an acronym, DRY, that means don't repeat yourself. So you'll hear programmers use that from time to time. It's one of those guiding principles that programmers try to follow. So imagine that you need some dental work done, and you go to a dentist's office that is a one-person show. Well, in this case, if you've only got a dentist working, then the dentist has to do a lot of different things. The dentist has to perform all the dental work. So these are the specialized dentist things that the dentist went to school for oh so many years to get their DDS degree. But then they also have to do some things that don't require any specialized knowledge. So they retrieve tools, they get the drill, they put the drill back, they get the extractor, they put the extractor back, and so on. And then they also have to worry about patient comfort, so they rinse and provide suction as they need to. So that would all fall on the shoulders of the dentist. But if you go to a little larger office, you might find that the dentist has assistants. So if a dentist has assistants, they can still perform the important work they have to do, but when it comes time to do some less specialized things, they can turn to their assistants and say, please hand me a tool. Please hand me that drill. Please hand me that mirror. Okay, here's the mirror back. Now hand me a curette. And she can also turn to an assistant and say, please rinse out the patient's mouth. Please suction the excess moisture from the patient's mouth, and that kind of thing. So if you think about this in terms of a program, what you'd see is that having the dentist do everything is like having all the logic of your program in the main method. If you want to delegate responsibilities to other parts of your program, that's more like having a main method that calls get tool in order to get a tool, or control moisture in order to do rinsing or suctioning. So that explains how methods can be used to perform tasks on behalf of the main method. But there's another important element to methods that make methods appropriate for object-oriented programming. That is implementation hiding. Implementation hiding is a very important characteristic of object-oriented programs. What it does is it keeps the details of a method's operations hidden. What that means is, from the calling program's viewpoint, the method is a black box. It's a box into which you cannot peer. So what you need to be able to do with this black box is to give it whatever it needs to do its job and take whatever it produces. As a calling program, that's what happens. It sends in its arguments and it receives back results. But the calling program has no idea what happens inside that box. It just knows what kind of thing it expects to do, what kind of thing it expects the method to do. So if we go back to the dental office, here's what that might look like. You have a main method, and represented here by the dentist, and the dentist needs a tool. So she'll turn to the assistant and say, I need a very specific tool. So at that point, she doesn't need to watch the assistant do what the assistant is doing. The assistant will just do it. So the assistant, maybe they look at the tray. If it's on the tray, they hand it back. If it's not on the tray, they look around for it. So they have to scrounge around a bit maybe. But then eventually they return the tool. And so at that point, the assistant returns control back to the dentist. So you could think of that as the get tool method, returning control back to the main program and passing back whatever the expected return value is. In this case, it's a curette. So that's what implementation hiding is all about. Okay, so now that you have those definitions under your belt, we could take a look at some actual method code.